Many thanks for staying with us on the program Aqua Farming. Welcome to your first agricultural television station. My name is Joshua Isha, your host on this very amazing program. Today on the program, we'll be looking at integrated fish farming. Integrated farming involving fish is defined broadly as a concurrent or sequential linkage between two or more human activity systems, of which at least one is aquaculture, fish in particular. Nevertheless, the linkages between aquaculture and human activity involve not only agriculture but also include roles in sanitation, nutrient recovery, hydroponic fish breweries, and energy recovery. Culture in heated affluents of power plants, dairies. In contrast, theologians used to differentiate integrated fish farming system from mixed farming, in which production of subsistence of a farm are not mutually supportive and do not depend on each other. The principle of integrated fish farming involves farming of fish along with livestock and agricultural crops. This type of farming offers great efficiency and resource utilization, as waste or byproduct from one system is effectively recycled. It also enables effective utilization of available farming spaces for maximizing production. In Nigeria, integrated fish farming has been reported in many states of the Federation, in which 50% of fish farmers integrate poultry, piggery, or livestock with fish production, while integrated fish crop production is on the rise, also in several states, according to the essence of integrated systems to increase the productivity of fish as to meet the challenges of food shortage and reducing the unemployment rates in Nigeria. On this episode of the program Aqua Farming, we'll be explaining and looking at integrated fish farming as the way forward to utilize the little land you have. Take a look.
Integrated aquaculture is a combination of aquatic organisms, fish, culture with other forms of agriculture such as poultry, piggery, cattle, goat rearing, and different crops in arable agriculture in such a way that some of the byproducts of these forms of agriculture that are considered as waste can still be recycled for the direct or indirect consumption by fish. Modern fish farming methods, with their high external input and economies of scale, may promise food but at risk of high production costs and environmental degradation. One option for sustainable development in farming is all small-scale integrated agriculture and aquaculture with obvious benefits of stability in production, efficiency in resources such and conservation of the environment. Uncertainty in markets and climate is countered by a wide array of enterprise in integrated farming, and moreover waste of one enterprise become input to another, and thus optimize the use of resources and lessen pollution. Fish are efficient converters of low-grade feed and waste into high-value protein, and fish products are the greatest source of animal protein in rural Nigeria. Adoption of integrated agriculture aquaculture will facilitate the addition of new resources flows, the integration of new enterprise, the substitution of external inputs, and rehabilitation of degraded agro ecosystems. The scope of practices in an integrated fish farm could be considerably wide, apart from fish cultured in the water body. The water surface can be used for goose and duck rearing, pond dikes for fruit and mulberry cultivation, or for setting up pig sites or slopes for further crops. The products from an integrated fish farm are not only fish but also meat, milk, eggs, fruit, vegetables, etc. It is apparent that integrated fish farming can fully utilize the water body, the water surface, the land, and the pond cell, etc. to increase food supply for the people. Integrated system of fish farming involves metered utilization of aquatic waters. Animal excreta alone cannot be effectively utilized through employing various methods and techniques. Fresh animal manure can be applied directly to the fish ponds, pig sites, poultry coops, and pens for ducks. Geese can be constructed on the dikes or above the ponds. Fresh manure thus enters the pond directly, avoiding energy loss due to processing of manure and transportation. The feedstuff of livestock are not only digested, and these can be directly utilized by fish. Therefore, the number of animals could be compatible with unit water surface. Animal manure can be used indirectly through one or two trophic levels in a food chain, such as growing fodder crops to feed herbivores, fish, or producing worms or other animals. For carnivores, fish directly, poultry manure can be used to feed pigs, and pig manure can in turn be used as fertilizer for fish ponds. In fish fries integrated culture, crop residues and compost are utilized in fertilizing the ponds, while the fish movement help in aerating the pond for healthy rice growth. Now, let's look at advantages of integrated fish farming. The advantages of integrated fish farming include the following. Number one, establishment of a man-made ecosystem without any unutilized waste, thereby improving facility of the local environment. The farmers obtain free pond fertilization from animal organic manure and also free pond after for animal husbandry purposes. It therefore constitutes a continuous process of disposal and recycling of animal waste which would otherwise be accumulated on land or washed via water courses to the river, thereby creating pollution problems. Number two, there are a maximal and efficient utilization of space and resources. Income generated by any of the combined system is higher than from pure fish culture, animal husbandry, or plant cultivation. Integrated farming can play an important role in national economy through the creation of more jobs and in augmenting production of animal protein and crops. There is no need for sophisticated and expensive fishing gear and craft interventions since simple training and harvest methods are used. The system has low operating and maintenance costs, thereby saving feeding costs, which is a major component in agricultural enterprise. Money that can otherwise have been used for feeding of fish can be diverted to other projects. The system is more efficient than sole fish culture in the utilization of primary resources such as organic fertilizer, feed water, land, and labor. It enables multiple uses of land that would otherwise have been useless, especially for arable agriculture. The farmer is enabled to make effective monitoring of the production system since both fish and other animals or plants are within the same environment. Decrease dependence on production input from outside the farm, such as artificial fertilizer, thereby increasing profit and ecological stability of the farm. Increase productivity and efficiency on the farm. However, a farmer needs to understand the stocking rate and the densities of the commodities cultured together to enjoy the venture. Now, let's look at fish species choice consideration in integrated fish farming. Will local or improved fish species grow well in rice field and adapt a shallow water, high turbidity and temperature on low dissolved oxygen condition of the field? Economically important and ecologically suitable. Catfish and tilapia. Now, let's look at fish cum poultry farming. Many small-scale farmers in tropics keep chicken which are not expensive to rear for meeting household needs for egg as well as meat. Chicken manure contains a lot of nutrients and makes very good fish food just like turkey, ducks and geese. This system of integration involves the building of poultry houses over a pond. If the farm is on a large scale, the chicken coop can be built on embankment of the pond as a figure. The poultry are fed in their enclosure and their droppings are allowed to fall directly into the fish pond or onto a platform where their droppings could be quantified before releasing it into the pond or stored. The advantage of poultry manure is that it has nitrogen, phosphorus, and organic compounds that are suitable for primary production in the pond just like fertilizer in farmland. Proceeds from the sale of chicken manure may exceed profit from sale of chicken and eggs. Research has established that a chicken produces 40 kg excreted daily, and therefore it is recommended that 10 to 30 chicken be stocked per 100 square meter pond area, and this could yield 50 kg. However, the size of the pond should always be put into consideration before erecting a poultry house. That is, a very big poultry house built on a small pond could be discouraged since the droppings of the birds will be too much and may thus contaminate or pollute the pond. A poultry housing must about 25 to 35 birds should be ideal for a pond of 15 meters and 10.5 meters for stocking catfish. In a situation where the fish pond is secondary in consideration to the poultry, It is better to construct the pond separately and then feed the fish manually with the poultry drop-ins. However, in a situation where the poultry is secondary, in which case there is a large fish farm to a small poultry attachment, then supplementary feeding from other source should be considered, since the drop-in alone from the poultry may not be sufficient for the fish to utilize. If the size of the poultry is proportional to the pond, additional feeding of the fish may not be necessary. In all circumstances, a close study of the pond and fish should always be made, especially if the birds are infected with disease, since this will affect their feeding habits and consequently less dropping. It should be noted that some poultry disease may also cause infections to the flesh and skins of the fish. The poultry house floor should be made in such a way that the droppings should fall directly inside the pond. Birds should come from fast-growing, well-feeding trained bred and crossbreed parents to convert feed into meat efficiently in shorter time. Birds should also be resistant to disease. Waste available already on farm. If so, the waste already used should be divided for use in fish culture. Poultry waters, poultry waste are often important as crop fertilizer and fuel considered the opportunity cost. It is what raising poultry, especially to generate waste for aquaculture. The bulkiness of poultry manure and the environmental nuisance of smelling are all waste to be used in fish culture. If some waste are to be used elsewhere, the waste should be collectible prior to entering the pond. Also, one should be available in larger quantities at certain periods when their use should be reduced for fish culture during cold season. Pens should be close to the pond to reduce the labor cost of loading waste. In the layout design, consideration must be given to size of number of poultry, space available, availability, and cost and relative cost of materials. Can all the waste be collected in deep litter or cage system? Poultry rearing are kept confined at all times so as the waste can be collected and used. Small-scale poultry farmers often allow birds to be free-range during daylight hours and only confined at night. This reduces feed costs considerably, often allowing only one farm or low-cost supplementary feed to be given, but collectible waste will be less. Ponds may be multiple functional, increasing the risk of water-transmitted disease. Ducks and geese are attractive. Now, let's look at fish-cum-duck geese culture. Ducks and geese are attractive poultry for small-scale farmers. Duck, a very common water bird with short legs and a wide beak, and geese manure also contains a lot of nutrients and are suitable for feeding fish. Ducks and geese swim in the fish pond, thus spreading their own manure. The amount of manure produced over a 2-month period is approximately 6 to 9 kg per bird. Ducks and geese grow quickly, are strong and easy to keep. They eat waste products as well as weeds, frog insect larvae, and snail. For the pond, it is especially good to keep ducks and geese if the farmer has a large amount of tender green growths or water weeds. Mixed with feed. These food sources can form a larger proportion of the feed for ducks and geese. Supplemented with less bulky feed such as grain, ducks stir up the bottom of the pond which looking for food. This reduces algae growth as sunlight cannot penetrate too deep into the water. By keeping the duck in one half of the pond only, algae can grow in the other half, which also provide food for the fish. They spend less time in the water. These food sources can form a large proportion of the feed for ducks and geese. Supplemented with less bulky feed such as grain, ducks stir up the bottom of the pond when looking for food. This reduces algae growth as sunlight cannot penetrate so deep into the water. By keeping the ducks in one half of the pond only, algae can grow in the other half, which also provide food for the fish. Geese spend less time in the water than ducks and more time on the banks resting and looking for food. The bank of the pond have to be fenced off so that they are not destroyed by the geese. Ducks raise up into water grow more quickly than those raised on land, and they are cleaner. One advantage of geese is that they are good guard animals. A minimum area of 0.5 per duck or goose is required. Ducks and geese can be housed in a variety of ways. A pen can be built which floats on the water or resting on tilt above the water or on the bank of the pond. Ducks and geese only need shelter for resting, which can be built above the pond or by the side of the pond. A shelter built above the water. A shelter built above the water must have a floor of slats or mesh, which will be the manure through ideally, and all the manure should be into the water, by fencing up the banks with wire or netting, and not building a shelter on the bank. One can ensure that all manure is deposited in the water, and that the dike, a wall or bank built, remain undamaged. In this type of integration, you can obtain yields of 30 to 55 kg. The yield will depend on the number of ducks per square meter and the fish species culture combination. A combination of tilapia yield 35 to 40 kg of fish per 100 square meter, when a higher density of Nile tilapia is used, up to 70 kg to 100 meters square can be harvested. The maximum number of laying ducks or geese is 75% to 100 square meter when capsucci are raised, while tilapia are raised, which are less sensitive to oxygen content. The 350 ducks or geese for meat or 400 laying ducks or geese can be kept, where catfish are reared. The number of ducks or geese for meat rises to 700 per 100 square meter, or 800 eggs laying geese per 100 square meter. Catfish can breathe in oxygen from their air as well as from the water. This means that the more animals can be kept per square meter and production level of 150 kg per 100 square meter be obtained. Ducks can also be reared in the vicinity of the fish pond by leaving the birds to move on the water bodies. The pond open to ducks can be stocked at the rate of 45 fingerlings. The dropping continually manure ponds and a huge quantity of phytoplankton be readily available. The ducks also clear the ponds by rooting up water plants and eating some of the fish predators such as reptiles, amphibians, and water snails. Apart from the direct manuring of the pond, ducks further produce additional dropping during their rest period when they converge in their house. The duck house must be constructed low enough to allow birds always go out to swim and come back to the house without any hindrances whatsoever. The material to be used for the pillar of the house should be hard, woody, that will last several years. Concrete cement or iron rods and better materials feeding of the ducks should be done inside their houses. Regular supplementary feeding of the ducks should be ensured to avoid a hungry duck searching for food. However, supplementary feeding for fish will not be necessary unless feeding is for a purpose, such as feeding the fish to attain the required size at a targeted time.
The Agricultural Research Council of Nigeria (ARCN) coordinates the activities of research institutes and is responsible for supervision, regulation, coordination of research activities and programs of higher institutions in Nigeria. And Professor Hamidu Shaributu, since assumption as Executive Secretary of ARCN in April 2020, has solidified the transformation of agriculture in Nigeria through strategic and meaningful execution of research findings for improvement of the agricultural sector.
The National Horticultural Research Institute (NIHORT) is one of the 15 agricultural research institutes in Nigeria under the supervision of the Agricultural Research Council of Nigeria. The institute started in 1975 as the Fruits and Vegetables Research and Demonstration Center with the assistance of the United Nations Development Programme (UNDP). It metamorphosed to National Horticultural Research Institute in 1976. NIHORT headquarters is located on a sprawling 350 hectares of land at Jericho area, Ibadan. To have a national spread and outlook, the institute has 3 outstations and 2 experimental stations. The outstations are Mbato, which sits on a massive 810 hectares of vast land located in the humid zone of southeastern Nigeria, Bagauda in Kano, made up of 110 hectares of land in the semi-arid zone of northwestern Nigeria, and finally a 156 hectare of farmland in Otukpo, Benue State.
National Horticultural Research Institute (NIHORT) has developed, registered and released 3 new varieties of tomato which are tolerant to fusarium wilt, root knot nematodes. They are high yielding, early maturing with good nutritional values. These newly released tomato varieties are Otitum 1, Otitum 2, and Otitum 3, and they are adapted to different agroecological zones of the country. To minimize post-harvest losses, the Institute has developed value-added products from tomato, such as tomato paste, dried tomato slices, tomato wine, as well as tomato juice. The Institute has also developed tutor trap tray to control tomato leaf miner, also known as tomato Ebola. Additionally, biopesticides have been developed in the Institute, known as Nihot Liptol, Nihot Ractane, and also the Nihot Sticky Traps, which are effective in the management of tomato.
The Institute for Agricultural Research (IAR) is located in Samaru, Zaria in Kaduna State. It was established in 1922 as the research division of the Regional Ministry of Agriculture in the defunct Northern Nigeria region. The purpose at that time was to research into problems of agriculture and to provide solution, and to enhance productivity in agriculture in northern Nigeria, including agricultural mechanization to reduce difficulties of operations such as planting, application of fertilizers and herbicides, drying. It also includes the development of improved crop varieties which are being planted by farmers in northern Nigeria. The Serious Research Program of the Institute, which is charged with the mandate to research into the genetic improvement of cereal crops like maize, sorghum, among others, has developed over 60 varieties of maize and over 46 varieties of sorghum, among others, which are high-yielding, pest-resistant, and drought-tolerant. One of major breakthroughs of the Institute is the development of maize varieties that are resistant to the fall armyworm. RAR varieties of cereal crops are also resistant to striga weed, a parasitic weed which attaches itself to cereal crops and absorbs the nutrient, causing poor yield. IAR has to its credit 29 varieties of groundnut, 21 varieties of cowpea, including the very newest variety that has high resistance to insects. This can save Nigerian farmers at least 16 billion naira annually in the purchase of insecticides.
Since then, Professor Shaributu has operated as visionary captain by restoring the council's glory with the first ever agricultural television and radio station in Nigeria, with well-equipped studios parading state-of-the-art equipment.
The Agricultural Research Council of Nigeria also has a brand new electronic library to further promote research and visualizations of deep thoughts on agricultural development in Nigeria.
The museum, located in the Senator Abdullahi Adamu Center, is an agricultural museum saddled with the responsibility of keeping records of agricultural findings, discoveries, researches for continuity and history purposes.
ARCN,
promoting agriculture. Many thanks for staying with us on the program Aqua Farming. I'm so sure you must have learned one or even more why you can go into integrated fish farming, saying that it is another way to cultivate different crops while you say cultivate your fish. On behalf of the crew members who made the program possible, many thanks for staying with us here on the program Aqua Farming, and the station has been your first agricultural television station, the Agricultural Research Council of Nigerian Television. My name remains Joshua Ishaya. Bye for now.